Test, sound test, sound test. Test, sound test, sound test. Howdy, y'all.
Hi there. I didn't realize that I got the stream started all early, and then I didn't realize that it was then after 11 as I was working on other stuff. So here, I'm going to do a sound check real quick. Sounds working. Boom. Okay. Here we are, Sunday stream. Hot chocolate. I've stopped drinking coffee. I've gone off caffeine. Obviously, hot chocolate has a little bit of caffeine in it, so but concentrated, like tea, like caffeinated teas, coffee, even decaf tea was. I'm feeling better now. I should try decaf coffee again. Howdy, and welcome to the Sunday Chill stream. Here to answer your questions, your math questions, or just other questions. I mean, if people submit other questions, I'll do my best to answer them. And I will admit where I don't have expertise. So, like, if you give me a calculus or a chemistry question, I can try to kind of look stuff up and help you find resources, but I'm not going to be able to like teach it or answer it off the top of my head. Calculus, on the other hand, I will be able to. That's my jam, right? Okay, we got our submission form there. Nothing there. Let's check our email inbox. Okay. Okay. Okay, yeah, I think I have everything going here. So, I'm Ryan, the calculus tutor. Welcome to the drop-in math help stream. I answer math questions that have been submitted to me. I answer them here, and then I email the people who submitted the questions. I email them back links to the timestamp in the recording of this stream, and the particular place in these notes here. There we go. Maybe show pictures on this one too. There we go. So yeah, you can submit your questions at any time at thecalculustutor.com/live. And I just answer the questions that I've gotten, and then send those back to people. So, if you tune in live, if you're here to actually watch the stream, you can ask questions in chat and, have that sort of synchronous interaction. But if you can't catch the stream live, I email you back links that you can use to participate. So top of the sessions, we're saying abolish ICE, or it's as simple as it sounds. ICE is unnecessary. We don't need undertrained, well-armed, mostly dysregulated men who are eager to do violence. We don't need them on our streets, and that's what they are. Effectively, state-sponsored terrorism, terrorists funded with, either your tax dollars or your parents' tax dollars. We don't need them. We don't want them. Abolish ICE. and I'm saying it to my representatives as well, I encourage you to do the same. Even if you're not old enough to vote yet, you can still call or message your reps. They represent you as well. Um, Seen a lot of activity from local young people, high schoolers, middle schoolers, even staging walkouts, go into the federal building, standing off with, I don't even know what to call them. They're not law enforcement because they're selectively enforcing. There's certain laws they're out there thinking that they're enforcing, but really they're just sowing chaos and creating terror in communities across the country. So we say abolish ICE, and we will keep saying abolish ICE until we don't need to say it anymore because it's happened. And that's a little of what I'm doing in this space right here. All right, let's talk about how you get your math questions answered. There aren't any math questions in the queue right now. I like to start off each stream with a quick little intro. How do you participate? So as you can see, submit your math questions at thecalculustutor.com/live. So if I'm not on the right page on my website. I'm just at the Calculus Tutor. My computer's being a little laggy. That is unfortunate, but you know what we can do? I can just use this computer to send it to this computer. Boom. There we go. I don't even need it. I don't even need my keyboard to respond. All right. Stop this stream. So that was the notes, the always available notes. But here is, oops. So if you go to thecalculustutor.com/live, this is the page you'll see, my dedicated streaming page on my website. And you can see the stream is right here. So you can, this is where you can watch the stream if I happen to be live. There's a button to submit notes. There's a submit math questions option here under the live stream thing, and also another way to get to the notes. You can click this banner to go to the question submission form, but if you scroll down, you want more information, here is the submit math questions little explainer section. Here's a button that'll take you to my question submission form. That's my preferred way, but you can always just email your question directly to me, to Ryan at thecalculustutor.com. I'll answer your question during the next live stream and then send you links afterwards to the specific sections of the notes and the stream recorded VOD where I answered your question. Getting math helps real easy. So oh, you couldn't see what I was doing because I was gesturing on my other computer. I am so sorry. So if we scroll down, this is the stream section, a place for the notes. There's under the menu, there's a submit math questions option there, and then you can scroll down. And we'll click the submission form button. And so as you can see, that takes me directly to this form. It might take you to a Google sign-in screen. In order to submit this form, you have to be signed into a Google account because you can attach files, specifically images, and that's useful. So you can snap a picture of whatever math problem you have a question about and send it to me, right? That way you don't have to retype the math problem. So sign in with a Google account. If you try your school Google account and it still won't let you in, that's because your school district has your Google accounts locked down in such a way that you can't even access a form outside of your school network. In which case, just go ahead and email me, Ryan at thecalculustutor.com. Right. So here's the form. Um, and so if you do email your question to me, everything I asked for in this form, you would be a good idea for you to include in your email. So this is just a guide to what to include, but here it's formatted just as a form that's easy to fill out. First of all, the checkbox to say, yes, I understand my email address is being recorded for this form. Tell me who you are. That's just your preferred name, however you'd like me to refer to you when I go to answer your question on stream, right? Because I'm going to be like, this question was submitted by such and such. So just let me know what name to say. It doesn't have to be your real name, just whatever name you'd like me to use. You could also include your pronouns there in this space as well. Um, if you don't, I'll probably just use they. And then tell me where the question came from. By that, I mostly mean, I assume most of the questions I get are going to be like homework or test prep questions. So what I want to know here is the teacher in the class this is from. So, uh, Mix Jeffries, Algebra 2, Mr. Smith's Geostats, right? Just simple as that. If it's not from a class, you can say it's not from a class, or you can be a little bit more specific about where the question did come from. That's mostly to help me organize, and eventually I want to have a bunch of these questions, you know, and my responses organized in such a way that people can search them, right? Um, and that because other people that take that class from that teacher will probably encounter that same question. But yeah, um, then there's a place for you to actually ask me what your question is about the math problem you're working on. Um, so you don't have to retype the problem because down below you can attach images. We'll talk about that in just a second. So right here is, the best thing. What you're doing here is the more specific of a question you ask, the more specific my help can be. But you're totally welcome to just ask me, you know, can you show me how to do this, right? Like that's a fine question, and I absolutely will. Um, but this is also a place because when you submit your question, I'm encouraging you just to take a picture of your whole textbook page or worksheet page, or take a screenshot, or if you have a PDF packet that's like on Canvas or something, just download that and upload the whole packet. So another thing that you ought to put here to help me know is the specific problem you want me to look at. So, especially if you send a packet, you might tell me the page number, you might tell me page 3, and then you might tell me numbers. Maybe there's a set of problems, you're not sure how to do any of them. So you're like 12 through 16 or something like that. Just direct me to the particular problem or set of problems that you'd like some help with. And then in addition, if you can, uh, tell me specifically what your question is about that problem. Um, or tell me what you're struggling with that problem, right? Like, how do I deal with the fractions? Right? Maybe it's a type of problem you've done and you know how to do it, but this one has fractions and that's throwing you off. And so that's really the thing that's making it difficult for you. Um, maybe not. Um, so yeah, just a place for you to ask me your specific question. Whatever problem you send in, I'll work it through. I'll email you back the notes and the link to my video where I explain what I'm doing. But if you ask a specific question, I will definitely answer that specific question about that problem. I'll work through the whole problem and make sure I'm really hitting on answering your specific question. We'll skip past this box right here for just a second and go down to the attach helpful images. Like I said, snap a picture of your entire textbook page, your entire worksheet page. You just want to make sure the instructions are in there, all the diagrams or charts or anything, even blank ones like that you're supposed to fill out as part of the problem. Make sure those are included because I'll put them in my notes and that's what I'll fill them out as I work through the problem. That way my notes look like what's expected of you. You can attach up to 5 images, including PDF files. So like I said, if you have a whole PDF packet you're supposed to be working through, you don't have to go through and like pick out, you could go through and just screenshot the specific questions, But if you send me the whole PDF, that gives me even more context for sort of what you're working on. Yeah, and if it's if it's a worksheet or something like that, um, you know, if there's relevant information to the problem on both sides of the worksheet, just send me a picture of both sides. Like I said, you can attach up to 5 images. Um, the other thing that you might include with those images, which is optional but can be very helpful to me in answering your question and giving you the best help I can, is if you include a picture of any work you've done related to that problem. So if you've already tried the specific problem you're asking about and you got the wrong answer or you got stuck at some point, send me a picture of the work that you did do. That's going to really help me see where you're at. Maybe you haven't, maybe you don't even know how to start the problem you're asking about, but maybe there's a similar problem. Maybe you're asking about number 13, but you did number 12 just fine. Um, Send me a picture of your work from number 12. That just lets me know where you're at and what you're doing. If you don't have that, you can send me a picture of problems you worked through in class together, like the teacher was working through problems and you were taking notes about it, or just notes that aren't problems, just notes about the topic. Anything you can send me that clues me into what what the teacher is expecting of you, what you were talking about in class, that sort of stuff. Again, just like one picture. You don't have to send me a ton of stuff. Just one picture of any work you've done related to that problem. That's completely optional. Like, you don't have to include that, but it will help me give you better, uh, just more complete and thorough support. My promise to you is that any work, any of your own work that you send in will not show up on stream. I know I understand that that can make some people nervous. They don't want, they're not out here trying to have their math work broadcast on the internet. My math work will be broadcast on the internet, but yours won't. That does bring us to this box. Can I share your work on stream? In general, I don't want to share your work on stream. However, there is a certain type of math help that some students, more like university, college and university students that are in higher level math classes, there's a certain type of help that they might want where I can, they might want me to go through their work kind of line by line, almost more like I would be doing an essay. And for that type of help, I need to be able to show the work, right? And so that's just there for them. If you're just sending me a work to help me get a better idea of what you're doing, don't check that box. It starts off unchecked. You're automatically opted out. That's there for the instances where people need to be able to opt in. Yeah, so that's how you submit a question. You just go to that form. We'll go back to the website. Remember, you can always just email your question directly to me. Include all the same things: your preferred name, where the problem came from, your specific question, if you have a more specific question, and then images. With email, you can include more than 5, but you can't really see a circumstance in which you would need to. And yeah, either way, because the form records your email address, and because if you email me, obviously I'll have your email address. Either way, I will email you back links to the specific place in the recording of this stream and the specific place in the notes. So these notes, this document is always available. Obviously after this, I'll figure things out in terms of, like, I will probably move on to new documents, but it will be there for as long as you would reasonably need to be able to access it. And because I would like to make my answers accessible beyond to people after you, who might end up with a question about the same problems, um, I'm going to endeavor to make this always available. So yeah, and then you'll get a link to this. It'll link to the specific place. So if I answer your question like way down here, that's where it'll link to, but then you're free to zoom out or scroll around or whatever and look at everything else as well. But I'll understand that the main thing you want to look at is the notes for the problem you sent in. And that's it. That's how you participate. And like because I email you back, you don't even have to. You don't even have to like make sure you can attend the next live stream at the time I'm doing it. Um, if you do, the advantage of watching me go through your question live is that you can ask like clarifying questions in the moment. You can ask follow up questions right there, right in the moment. But even if you can't catch it, like I said, I'll email you. You can always respond to that email and ask follow-up questions, clarifying questions, things like that. So you don't really lose anything other than the timeliness of the synchronous interaction. Um, yeah. Um, I do also offer just one-on-one tutoring. Um, so there's more information about that on my website, thecalculustutor.com. So if you'd like to be able to have like a dedicated hour with me, um, it's not live streamed, it's just me and you. It would be via video chat, but it would be dedicated time for you where we can have that back and forth if you want help test prepping or you're struggling in a math class and you just need help sort of catching up on the concepts and the skills and stuff like that. Um, you can always schedule a one-on-one session. And there's information about my rates and things like that on my website. So, oh, the stream will begin soon. Stream has begun now. I always forget to delete that. Oh, wait, hold on. No. Okay. There we go. Cool. Now we can delete that. So I do kind of I have some math questions I worked on with a one-on-one student I work with, but nothing that feels terribly pressing, like, oh, this would be a good thing to go over with everybody. I did that during the last stream on the Wednesday stream. Actually, on the Tuesday stream before that is when I went over the problem. So here's you can't see what I'm doing. I'm interacting on the wrong screen. So here's Tuesday. We went over this word problem that I worked with a one-on-one student, and talked about how you make sense of a problem like this and how what you got to do is focus on the rates. Um, and then that led to us solving a quadratic down here. And we use the quadratic formula, but I know students in this class have also been focusing on completing the square. So Wednesday, that was sort of the main topic for Wednesday, was this process of completing the square, which is just a different technique for solving a quadratic equation. Like the quadratic formula, completing the square always works, which is kind of cool. Honestly, I think they're equivalent to each other. I think what ends up happening, maybe not. I'm just I have a suspicion that if you do completing the square with a standard quadratic. Well, now I'm curious. So maybe that's something we can talk about really quick. I need to set up my streams for the rest of the week, but we still have an hour and a half in this stream. So let's so I have this question in my head right now. Is the quadratic formula just the result of completing the square on a generic quadratic? So that's sort of the question that just sort of occurred to me and that I've thought about before, but I haven't ever actually investigated. So what do I mean by that? So our generic quadratic is just, how do I want to do this? I want to color code some things. A x squared plus bx plus c equals 0. This is our standard form of a quadratic, right? And that's the form we'd want it in for the quadratic formula, which we talked about a couple sessions ago. I'll remind us what it is. But so here's what I want to do. I want to go through the process of completing the square on this, and see what happens, right? So now we're going to solve by completing the square. And I went through completing the square on Wednesday session. So if you are interested in that and you want sort of a justification for it, where like why we do it, how we, that sort of stuff, check out that stream. So so solve by completing the square. So I'm going to grab this. Oops. That wasn't grabbing it. That was scribbling. Duplicating. We're going to take this down here. So zoom back in. Okay. So there's our generic quadratic equation. We want to solve it by completing the square. So if you remember from last time, our steps here, we're going to we want to move that constant away so we can turn this into a perfect square polynomial, which just means this number needs to be half of this number squared. So here, what colors do I want to use? Let's use, sorry, getting distracted by choosing useful colors. So we will subtract this C, subtract C over there. So we end up with, do I want to keep color coding these? I do like it, color coding it, so we can always see where the relevant values are. And now it's going to equal negative C. Oops. Negative C. There we go. Okay, so then what we need to do is take half of the middle term. It's b, so half of that is just b over 2, and we need to square it. So we are going to, here, we're going to do plus b over 2 squared, and we'll do that on this side too, plus b over 2 squared, like that. So over here, we have a x squared plus bx plus, now I'm going to write this as b squared over 4, 2 squared is 4, equals negative c, also plus, and this is the magic of, this is the completing the square process, but we have to do it to both sides just algebraically, right? Plus b squared over 4 as well. We'll actually multiply out the square on both sides. So the entire reason we did that on this side is because this is now a perfect square quadratic, perfect square polynomial, which means it factors into identical factors, just like 25 factors into 5 times 5, right? It factors into two identical factors. So we could write 25 as 5 squared. If we were to factor this, we would find, oh, you know what? No, 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 not yet. No, we have a leading term. We don't want a leading term when we're doing completing the square. Oh, okay. So, haha, we're not done yet. This isn't a perfect square yet. But if I divide everything by a, it should be a perfect square. No. Okay. No. We're gonna go backwards. We're gonna go back. Yeah. I'm getting rid of all of this. Sorry about that. Led you astray for just a second. I totally forgot about that a. I've been rewriting it. Okay. So what we have here, we have ax squared plus bx equals negative c. When we do completing the square, we don't want a leading term on the x. You can have a perfect square polynomial that has a leading term, but in my experience, the process is easier if you just divide that a out, and then you can use the simpler, and there's less to consider. So we're going to divide everything by a, right? Or another way to say it is we're going to divide this entire side by a, but that means when you have addition or subtraction, that means dividing both pieces by a, right? So dividing that whole side by a is the same thing as dividing both pieces by a. We did that to cancel out that a there. And so now the equation we have is x squared plus b over a times x equals negative c over a, like that. Now this is set up the way we want. So now what we would do is we want to take half of this, right? So just as a little aside over here, we can say b over a times a half is just 1 over 2a. So that's what half of b is. And then if we square that, 1 over 2a, oh, it's not 1 over 2a, it's b over 2a. I'm so silly. And then so that's half of our middle term, half of our what was our b, and we want to cut that in half, and then we want to square that and add it to both sides. So this is the completing the square step. We take this left-hand quadratic that isn't currently a perfect square, and we make it a perfect square. So b over a times x, and now what we're going to do is we're going to do plus this b over 2a squared, like that. But if we add it to that side, we add it to this side to make this a perfect square. This is now a perfect square quadratic, and we know exactly how it'll factor. But if we do that here, we have to do it on this other side as well. So really quick, we have to, oops, wrong button. So this will be c over a. And then that'll be plus this b over 2a squared. Let's move that away just slightly. There will be a Shut It Down Strike Action Report webinar at 7 p.m. Right. There's a Eugene City Council meeting tomorrow. Okay. It does look like I'm taking, sorry, tangent in the middle of this problem. It does look like we're probably headed towards a nationwide general strike. Minnesota did a general strike and it looks like it's extending after the events yesterday, the day before. I don't even, I've lost the timeline. And as students, you can participate. You can refuse to go to class. I think your teachers, I would hope teachers are participating, but I understand the quandary and the conflict there for teachers. Anyway, support if you can. Oops. All right, so we've added our perfect square term to both sides. The reason we did that, that's strategic because that means this side here is what we call a perfect square quadratic, which means it factors into x plus this half term plus b over 2a all squared. And now if we were to multiply this out, x plus b over 2a times x plus b over 2a, if we were to multiply that out, it would just turn back into this. So this is the factored form of this, just like 25 factors into 5 times 5 or 5 squared. That similar type of thing, just with polynomials, with quadratics. And then over here, we'll go ahead and multiply this out right here. So let's get our values in here. This is going to be a C. This is going to be an A. This is going to be an A. And up top is going to be a B. And now the B is squared. This is a 4. And the A is also squared. Right? B is B squared. 4 squared is 2 squared is 4. A squared is A squared. Excellent. Okay. Now remember, what we're trying to do is solve for X. Right? That's our goal with completing the square using this technique. We're solving this quadratic. And the reason this is useful is we took a quadratic in standard form where you can't isolate the x in that form. There's no way to, when you have an x squared being added to a non-x squared, to combine those or get rid of one of them or anything like that algebraically. So we do this instead. And now look, there's only one x. All we need to do is undo this square and subtract this value and we'll be done. So I do see that we're going to have to take a square root here. And that we have to take the square root of the whole other side because of this addition. So I think what I want to do is I want to combine these together into a single value or a single fraction, right? In order to do that, we need a common denominator. So over to the side, a little bit of side work. I'm gonna work this out. Negative c over a plus b squared over 4a squared. So this one has an a in the denominator, so does this one, but it also has a second a and a 4. So that's what we need to multiply both sides by. So that's what we're going to do right here. We're going to do times, oh, you can't hardly see that. We're going to do times, and we have to do top and bottom so the fraction doesn't change, 4a over 4a. If we do that there, then this one becomes negative 4ac. I'm just rearranging those. And I'm putting the negative up top over 4a squared plus b squared over 4a squared. Okay, cool. And now I can combine these together into negative 4ac plus b squared all over 4a squared. And now I'm going to do another little thing. I'm going to rewrite this as b squared minus 4ac. That might look familiar to you. Hopefully it looks familiar to you. Oh, I wrote 4ac on the bottom. I meant to write 4a squared. There we go. All right, this is starting to look familiar. I think we're on a good track. So now I'm going to rewrite, now that I figured out this fraction arithmetic, I'm going to rewrite this. Let's just grab this. We'll duplicate it, put it right below. Okay, sorry about that. And then that's going to equal over here this single fraction that is b squared minus 4 times a times c. And on the bottom, it's 4 times a squared, like that. All right, so we have it. This side equals that side. All right, so all we have left now is to finish solving this. So let's do that. To get rid of that squared, we'll take a square root, which means we have to take the square root of this whole side right here. Remember, when you're taking a square root as part of algebra, you get a plus or minus. So we don't get a plus or minus here because it's just canceling out the squared. Anything squared, yeah, anyway, because it's just canceling out the squared. But over here, we get a plus or minus because the square root's just asking what number times itself equals the thing inside. So like 9, 3 times 3 is 9, but negative 3 times negative 3 is also positive 9. So you have the plus or minus version. Always, when you take a square root as part of algebra, the non-canceling square root gets a little plus or minus. So over here, we're left with x plus b over 2a. And over here, so this square, when you take a square root of a fraction, you can take the square root of the numerator and the denominator separately. So like, for instance, the square root of 9/16 is just the square root of 9 over the square root of 16, which is 3 over 4, right? So you take the square root of each separately. So what I'm going to do is I'm going to put a this plus or minus, right? A negative in a fraction can either go with the top or go with the bottom. I'm going to put it with the top. So we're going to get plus or minus. This whole thing doesn't have a nice square root. So I'm just going to leave it inside a square root. B squared minus 4. Oops, I need to color code my stuff. Sorry about that. B squared minus 4 times A times C. Here, give me 1 sec. My heater kicked on and I'm plenty warm in this the sweatshirt that I'm wearing. It's a chilly day, y'all. I'm gonna go ahead and shut this. All right. And then the denominator here is going to be 4. Oh, wait, no. We're taking a square root of it. Remember, square root of the top and square root of the bottom. The bottom, though, we can take the square root of. Square root of 4 is 2. Square root of a squared is a. Hopefully, this is starting to look very, very familiar. Now what we do, we're just adding this fraction right now. So only thing to do is just subtract the fraction. Subtract b minus 2a. Or we'll do subtract b minus 2a. So over here, it'll cancel out. And yeah, for problems like this where it's kind of long, lots of steps, obviously lots of stuff is scrolling off the screen. Remember, on my website, there's buttons and links that take you directly to these notes. So you can scroll back and look through the notes, at your pace. And, if you want to look back at something I wrote that's off my screen currently, though, if you're in chat live, you can ask me to scroll back up if you want. I just assumed it'd be easier for you to be in control of where you're looking in the notes. And then when you're looking there, you can watch me. You can just be watching your screen of the notes and you can see me filling this out live. Like it's an interactive thing. You guys can't write anything in there, but you can watch me write stuff. All right. So over here on this side, all we have left is x. So we did it. We solved. Over here, we have this plus or minus square root. We have a 2 here. Minus this. We also have a 2 here. So we have A's, we have A's, we have an A probably there, we have a 4 here, it's being squared, we're subtracting. Sorry, I'm getting my stuff all in here. So I don't have to keep swapping back and forth with the colors. So there we go. Notice these have a common denominator, so we can go ahead and subtract them, but instead of doing this square root minus b, I'm actually going to rewrite it so it looks more familiar. I'm going to put the negative b first. I'm going to say negative b, and then the negative b, and then the negative b is plus or minus that square root of b squared minus 4ac, and then they share their common denominator of 2 times a, and there we go. We solve for x. We solve the generic quadratic for x, and the result was a quadratic formula. So there you go. That's where the quadratic formula comes from. I was pretty sure that's how you derive the quadratic formula, but it's been, and I probably did that in high school or college or something at some point. There was probably a problem that was, use completing the square on the generic quadratic just as practice. Which means, what that means though, so here's some interpretation, what that means is that solving by quadratic formula and solving by completing the square are the exact same thing. The quadratic formula is just skipping all of the figuring out of completing the square, because it will always, when you complete the square and solve by completing the square, you were just always doing all of this math. But when a, b, and c are actual numbers, you never end up with b squared minus 4 times a times c. You just do those things as they happen. You square the b, you multiply the a times 4, you multiply the 4a times c, right? Like all of that stuff happens, and you never actually get to see it like spelled out. So that's why it's useful to solve generic equations, to look for the pattern. Say, wait, I follow the same steps every time, so don't I end up in the same place every time? And you do. Get my glasses. And in fact, like a lot of the there's a lot of stuff in math that you learn as separate things, but they're actually the same thing. Pythagorean theorem, Pythagorean theorem, but like law of sines. That's what I'm trying to say. Law of sines is just Pythagorean theorem, right? A squared plus b squared equals c squared. Sine squared plus cosine squared equals 1. those are the same equation. It's not that they look similar, they literally are the same equation, just swapping out side lengths, generic side length names A, B, and C for their trigonometric equivalents. Um, sine of some angle is just a length, a vertical, typically a vertical length, and then we're squaring it. So we're taking the side of a triangle, and then 1 is the hypotenuse, because in the unit circle, the radius is always 1. And any right triangle you make in the unit circle uses the hypotenuse as its, or sorry, uses the radius of that circle as its hypotenuse. Or any right triangle you make to a point on the circle, right? To be really specific. Yeah. So there's that, which means, on kind of a technical level, when you have one of these tests where your teacher, like, where the instructions specifically say use completing the square or use quadratic formula specifically, like if you're somebody who doesn't like the completing the square method, but you're fine with quadratic formula, you could just use quadratic formula, and you could make the argument that if your teacher's like, well, no, I marked you off because you're supposed to do completing the square, you could make the argument that quadratic formula is completing the square. And you could make the argument, why would I do all that work again when I've done it once to create the quadratic formula? All right. So we did a thing. We did a math thing. I could potentially cut this out and cut out some of my asides and my walking away and stuff like that. I could edit this probably and just put out a video that shows completing the square. If you complete the square on the generic quadratic, you obtain the quadratic formula. Oh, that's so nice to have that hot chocolate. So so I guess what I need to do now is I need to prep for the streams for the coming week. So do that, I suppose. Oops. Huh. Interesting. Why are you not? wait. Yeah, you go there. You can go there. Nice. There's that. So my Tuesday stream will be the 27th. There. Get that one. We can lock in place. Then my Wednesday stream, that means, will be the 28th. I opened up DevTools. Okay. And then the following Sunday will be the 1st of February. Oh, excuse me. There we go. Okay, we got the notes prepped for next week. Now we just got to prep the streams. There we go. Right. I'm gonna set up the. I'm doing it on this screen. Let's see here. Six, 127. So Tuesday's stream is Tuesday's the night stream, so that'll start at 9 p.m. And then the Wednesday stream will be at 3:30, so after school. And then we'll also schedule next Sunday's stream. It's nice to do this. And then the Sunday stream will be at 11, as usual. Cool. Well, there we go. There's that. Okay, there's the payment processed. Mhm. So, I don't really have much else for this. I think I might just call it here, y'all. I'm trying to settle more into this. So, with the idea of people can submit questions anytime, and then I'll answer them during the next stream, I'm perfectly happy to start adding more streams. So, essentially, I'm answering questions every day. That would totally be fine with me. Uh, or like at least 5 days a week type of thing. Um, that way, people can get a more timely response. Um, and so what I want to, I think what I'll, what if I can, once that starts happening, I will, I don't need to, I don't necessarily need to hold myself to some arbitrary length for these streams. I'll have a set time when I'm starting the stream, work through the problems, and then when there's no more problems to do, um, I'll just be done with the stream. I can end the stream. And that's what I want to head more towards. So I went through this. Nobody submitted problems. I wouldn't assume because there's been no viewers or anything. So, excuse me. So yeah, so I think I'm just going to call this here. Yeah. Oh, I don't want, sorry. There we go. Yeah. Hope all of nobody watching this has a good rest of your weekend. I guess I'll say it at the end too. Abolish ICE, abolish ICE, abolish ICE. There's really not much more to say about it beyond that. That sort of encapsulates the whole sentiment. Hope you and yours are well. Care for yourselves, care for each other. And I'm here to help. Message me if there's some way I can. See you on Tuesday.